afternoon, everybody. Welcome to the Triangle Area SQL Server Users Group. This is a special meeting on a Friday afternoon so that we can have a session that's not at an awful time for our speaker. So as we're getting this set up, our speaker tonight, whose name I promised before the stream I would butcher, so I'm going to do my best to butcher it, Erland Sommarskog. And I figured if I spoke it fast enough, then nobody would notice how poorly I pronounced it. So we will talk about dynamic search conditions, and I'm gonna switch over and hand it straight off to Erland.
Right, then I'm gonna try to share my screen. Share, and yep. Okay, you see it, let's see that. Now I'm gonna find my mouse and just so let's see how slideshow. Okay. Yeah. Okay. So welcome to this presentation. In case you didn't get my name correctly, when Kevin said it, my name is Erland Sommarskog, and yeah, I'm going to talk about dynamic search conditions. So just a little bit briefly about myself. I live in Stockholm, so I'm 6 hours ahead from you. So it's not actually quite a nice time for me. I'm not the kind of person that goes to bed very early. But having it midnight, if you would have your regular 6 hour clock, would be a little bit late for me. Anyway, so I work here as an independent consultant. I've been an MP for SQL Server for many years. I have my website, sommarskog.se, which you can say is a small collection of large articles that goes in depth in a couple of topics. And one of these articles is called Dynamic Search Conditions, and this talk is drawn from that article. There is also my email address. If you have any questions during what you come through right now, you drop them in the chat and Kevin will give them to me. But in case something comes to your mind afterwards, when the whole thing is over, just please feel free to drop me a line at SQL slides and scripts for this presentation is available on my website right now, sommarskog.se/present. You will see this link at the end as well. So what I'm going to talk about then, dynamic search conditions. So what is this about? Well, so in many systems or many databases, the users want to be able to search the data for all sorts of things. Just imagine, for example, an order database. Well, they want to find order ID, of course, some date interval, the customer name, the customer city, the customer's shoe size, you name it, or product ID, product name, discount code used, or etc., in combination, etc. And of course, they want correct results for the searches. And not only that, these evil suckers also want good performance for whatever the condition they put in. And that is the challenge we're going to tackle tonight. We're going to work in a database called Northgale, which has 1 million orders. This is an inflated version of the database, the old demo database from Microsoft called Northwind. And it's a Gale, so a little bit stronger. But the real production database might have, well, let's say 100 million orders. Now, Northgale is big enough to tell us that some solutions aren't good enough, but we will also have to use our imagination. The fine print there is just instruction. If you do the download, you need 2 scripts to build the database. So, there's 2 ways to go for building searches, static SQL and dynamic SQL. And it's not that one of them is better than the other. It's simply this, that they supplement each other very well, because where one is poor, the other is strong, and vice versa. And what it really boils down to is a matter of complexity. So if the problem is simple, it's just a stack of conditions, there might be many, but they all follow the same basic pattern, then static SQL tends to be the best one because it's quite simple and straightforward. But if you add more things sort of in different, well, as we will see some examples of this, sorting, for example, there are other complications. The static solution with static SQL tends to grow with the complexity sort of exponentially. Whereas dynamic SQL, you start at a higher level, so it's quite a lot of hassle from the beginning, but complexity tends to grow linearly, fairly decent slope. I will start talking about static SQL, and then we will go dynamic. And this is the search task we're going to work out most of the time. So first of all, I pick a bunch of columns. And then here, well, let's see here. I have an orders table, which I join to an order details table. Then I join into the customers table and a products table. And this, well, from a join clause, that spans a search of order lines. And that is what we're going to search around. In a real life problem, maybe if we search for a product, maybe we would like to see the full order or whatever. But that would be a little bit too complicated for this session. So we're just going to search in this simple space. And here are the search parameters that will be present in all searches. We will add a few more for some examples, but these are the basic ones. We have an order ID. So that's going to be searching for a specific order. There is a status column in this database, and this order can be either new, processing, an error, or completed. And 99% or more of the orders are C. Therefore, there is an index on the status column, but it's a filtered index. So we have excluded the C values because they are completely pointless to index. And we can search from the from date or to date and combine these. We can search on the customer ID, and that's an NCAR5 in this database to search for a specific customer. We can also go by the customer's name, and that's a start with. So if we enter BLA, that could return, well, it will return both Black and Blake and whatever else that starts on BLA. We can search for a city that the customer comes from, a region, a product, either by ID or by name. And well, all of these columns do have indexes on them. So we would like to use the appropriate index when we make some searches, and that's kind of part of the challenge. And here, let's move over. This is the general pattern for doing a search for static SQL, the logic from it. So we say, well, order ID equals an order ID, or we don't, order ID was not. So if we did not provide an order ID, we don't care about that one. And if we, the same thing here, order ID equals that status, or status is not. Order ID greater than or equal from it, or from it is not. So if we did not pass from it, that parameter does not apply. So if we pass no parameters at all, we will get back all order lines, yes. And well, customer name, like customer name plus %, etc., etc. Now, so as an example here, how actually this works. So this search will give us all orders from Tuesday on from customers in Durham. So, well, we did not provide an order ID. So since order ID is null, well, this condition does not mean anything. And we can take out this one as well. And we can take out all of them. And since from date, we know that from date is not null, and since it's not null, well, this is what we have left. So basically, all makes that this is the logical thing we have to work with. That's the general pattern. Now, how does this work in practice? What about performance of this simple solution? Let's have a look. So here I got this procedure called static search 1. And you can see here, I got all the parameters that I showed you, and all of them are nullable. So I can only provide those that we need. And here I got my select list, my join conditions, and here is the where clause. And I will go and create this guy. And well, as a first quick thing, I will make a search in order ID. Oh, it seems to return the result very quickly. Now I'm going to run 3 searches, one on order ID, one for new orders, and one for a product ID, specific product. And then I'm taking the time of all of them. So I'm first capturing sysdate time, and then I'm trying to getting sysdate time afterwards and computing the difference in milliseconds, so I can see how long time each search takes. So I'm going to start and run this. And this one was quick, 203 milliseconds. Users can certainly accept this. However, the searches on new orders are 6.6 seconds. That's a little tad above their patience. And the one on product ID, yeah, it's still going on, and it's still going on. And while it's going on, I can report that tonight we had some rain here in Stockholm. Yeah, this one is, it's taking too much time. That's definitely not good performance. We will have to work harder. That's for sure. And yeah, this is the pause of the presentation the place in the presentation where I just have to just talk and talk. But I think this is about the only place I need to do that. Yeah, it took 35 seconds, which is of course completely unreasonable. Now, but before we leave this solution, I'd like to show you one more thing. What I'm going to do now is I'm going to force a recompile on this one, and then I'm going to rerun again on product ID. But now this was quick. And then they're going to run all these searches again. And now, well, the last time the search and order ID was quick, but now that one is taking a long time. What is going on here? Well, what is going on, I can explain what is going on. Because, I mean, this is a stored procedure. This is a static query. So there's one single query plan for this one. However, how this query plan is built depends on the input parameters. So what SQL Server does is it sniffs the input parameters and see, okay, I got an order ID. Then I'm going to optimize this plan is going to be quick for the order ID, this specific order ID, or a product ID, whatever I put in. So that's why it was quick the first time for the order ID. Now this time we have a plan optimized for a product ID. So that search is fairly quick, but well, it still hasn't completed, and it's been running for 44 seconds for an order ID. I think I got to move on to the slides. Oh, here it comes for the order ID in 50 seconds. It's usually actually, my laptop is unusually slow tonight. It usually takes like 30 seconds. Anyway, I'm not going to wait for the other one. That takes too long time. So just to summarize, the plan, which you see, is optimized for the first search, so-called parameter sniffing, but this does not fit the other search conditions, because we would like to use the specific indexes that are for each condition. So we need different plans for different search conditions so we can utilize the indexes for the parameters that were actually passed. Before we move on to look at a little sidetrack, because every once in a while when this comes up in forums, there are always those people say, no, use this instead, this is faster. So rather than using the order pattern I had in the previous slide, you suggest is null. So I have already, is null, it already equals already. Oh, okay, so if this one is null, we have a truism here, already equals already. Well, looks like at least it's slightly shorter, but is it faster? Well, let's have a look at it. And yeah, you can see now how it goes. 4 to 7, but this one was decent. But anyway, here we have the same parameters, but I've rewritten this now, so we got this is null pattern, and there is a search, and I can run all this, and I'm in for a nasty surprise, because it doesn't really matter if this is quicker or not. The result is wrong. I don't get in the rows back. And why is this? Well, this is because if we go here and look at the orders for this, or look for this customer, the column region is null. So if we now go here and look at this condition here, well, we have C region equal is null C region. So this one is null. Okay, C region equals C region, but this is null. And all comparisons with null in SQL Server, that deals, yes, unknown, because, well, the null is an unknown value and may or may not be equal to the other value we are comparing to. Well, in this particular case, it is definitely equal because it's the same unknown value, but there is no special room for that. So, yeah, the whole full story is simple as this: that we would use this pattern. Rows with null in a nullable column would be filtered out when they should not be. So do not use this pattern. It's just bound to cause accidents. And of course, no, it does not run faster because it's still a static plan. It still has the same problem as the previous version. Okay, so let's now look at different plans for different search conditions. So there is this thing we can put on a procedure, create procedure with recompile, and that compiles the procedure every time. Does this help? Let's try it. And so you see, I got with recompile. I've gone back to the pattern with or, because this is the pattern you should always use. Never use the is null pattern. Of course, the is null pattern will work if you have not null columns, but why? I don't like using things that only work sometimes. So anyway, I'm going to do my searches again and get the execution times, the search on order ID, the search on new orders, and the search on the product. And it's definitely faster. These execution times are, well, decent. Users are likely to accept these, but this is the database with only 1 million orders. And in production, we have 100. Is there any way we can find out if this would be faster enough in production? Well, we can take a look at the query plan. So let's do this. We would like to think here now, because we're make a search in order ID, that we're using the clustered index, the primary key, on the orders table. Let's see if this actually happens. And we'll go over here to the right, and it says index scan orders ship IDX. So it's making a scan on the table. That's not really bad, because that's not really good, because this means it took now, let's see, was it 300 milliseconds? So imagine now we're doing this in 100 million orders. It's a 100-fold volume. It's going to take 30 seconds. No way users are going to accept that. So it does not seem like to be a success. But before we look into why, let's just make a second attempt for the status column. We hope to use the clustered index, the filtered index on the status column. But it says clustered index up here, and oh no, it's a clustered index scan. Again, a scan. So what's going on here? Why? Because you might think here, now we're seeing with recompile, so then it could actually use the index. Why not? Well, the problem is this: it's still sniffing the input parameters and it's optimizing the plan for the order ID, for status, and for product ID. But the optimizer must still cover up for the possibility that there could be something like this here all of a sudden. Let's say if, never type in the demo as they say, particularly not if you're such a bad typer like I am. But if from it is null, set from date, well, we only then wanted to search from the beginning of the year, for example. And the optimizer does not know this because the optimizer is only looking at the statement at the time. It's not making any sort of flow analysis of the entire procedure. So it must cover up. And therefore it must construct a plan which is correct for all possible values. It can sniff the input values and optimize for that one, but it must still keep its rear parts clean, so to speak, and make sure that the plan is always correct. So now, well, again, better performance, but not optimal. We got scans instead of seeks, and because the input parameters are sniffed, but the optimizer must consider that they may change. So therefore, we need to look for something else. And the next thing we could try is this hint, optional recompile, that we can put at the end of the statement, which tells the optimizer whether we should recompile that statement on every execution, or if it forces the optimizer to recompile the statement on every execution. So let's try this one. And so no with recompile there, but instead it says optional recompile down there. And I'm going to go and create this guy. And I'm going to run my searches again. Yep, seems well, 18 milliseconds, 343, 421, a little bit faster. But again, still a small database, but we could try the plans again and see what we get. And let's see here now. Oh, clustered index. Clustered index, it says, oh, wait a minute, I should, of course, get the hint first. Yes, it says clustered index seek. So it's now going straight down the index tree, down to the column. This means that if we have 100 million orders, it will be more or less the same execution time. Well, there will be fewer more reads because the tree index tree will be deeper, but we can ignore that. So yes, this seems like a good thing. And we can do this one as well, the new orders. See what plan we get here. And it says index seek orders status X. So yes, it's using the filtered index. So why is this working so much better than the other one? Well, now we're only recompiling this statement. So SQL Server can say, well, wait a minute here. Okay, so we're already at already is not. I know that already is not. I just take this thing out. And well, I can take all, let's say, for example, I'm making the search on new orders. I should clarify that. So I'm making the search on new orders. I can take all these ones out as well. And yeah, I can take this one out as well. I don't need this one. And I know that this one is N. So it's the same thing as I actually had submitted this query. The optimizer can just remove everything that is have no importance and say, yeah, this is it. And therefore, we really get different plans for different search conditions with the optimal indexes used because all other things are removed. So this is the key to success. But wait, there is more to it. Not because here, as far as we've seen here, we got, well, depending on the profile, we get different indexes. But there's more interesting things here. So down here, I got two searches with the same profile, a customer ID and a date interval. But they're still a bit different because this customer, ERN2C, has the most number of orders in the entire database, whereas this guy, Bolazar, has a single order. This here is a full, this interval here is just a single day, whereas this is a full year. So I'm going to run all these, both of these, and look at the plans. And we're going to go to the right, and you can see here it's making index seek on the order date index and an index seek on the customer index. So it's actually using both indexes on the table and then making a hash match of them. It's not a common that you see in this plan, but in this particular case, we got that one. Let's now look at the other one. Let's move out to the right, and we can see it's only using now the customer IDX, and this one down here is a key lookup. Of course, because we're searching now for an entire year, and I think this database has order for like 6 years or something like that. So that's basically 1/6 of the database. That's not good to use an index. So not only do we get different plans for different search conditions, but also depending on the value, we can get optimal plans when we use optional recompile. So this is the key to success. So because the SQL statement is only the SQL statement is recompile, all variable can be handled as constant. SQL Server does not have to bother about, oh, wait a minute, the values could change. No, because it's just this statement. And to get performance with searches with static SQL, you always need this hint. Well, almost I've said in parentheses. There are a few exceptions. One could be that, well, you don't actually have indexes at all, and the data set is fairly small, maybe let's say only 50,000 rows. And then, of course, it doesn't matter which combination you will use, because it will always be a scan. And there's another situation we will look at, a little more interesting, we're going to look at a little bit later. But for most of the time, you want this. You need this hint. One thing also to point out for those who are still on very old versions, if you're on 2008, well, first of all, you need a 2008 or late and be on the latest service pack. The hint was introduced in SQL 2005, but it worked differently then. And there is also some build of 2008 with that behavior. But you shouldn't really be on any of these versions anyway, because they're not supported anymore. But now you may ask this, yeah, okay, but that's nice, but this compiling, isn't that expensive? I mean, the cache is there for a reason, isn't it? Well, as often with these discussions, it depends. Well, let's say the users are only making a few searches per minute, and it takes 50 milliseconds to compile, and that's not a problem, not the least if that's where it's able to slash down the total execution time from 5 seconds to 200 milliseconds. Then you're actually making a lot of gain. But now imagine that you're using this static search for to look up orders by order ID 100 times a second. Now that is going to make your CPU really, really hot. That's bad. So if you have this situation, well, if you know that the search and order ID is very frequent, you can do this. So you have one branch here, check if order ID is not null. Well, order ID is equal as order ID without or state order ID is null, but then you tackle all the other conditions as far as they're applicable. Well, in this particular one, they are not really applicable. You have to use your imagination a little bit, and you don't have any option recompile. Whereas down here, you don't have the conditional order ID at all, but you have option recompile. So the net effect, here you have a cache plan, and here you have compilation every time. Now it goes without saying, if you do this, your code will be more difficult to maintain, and you can do 2, maybe 3 branches, but hardly more, then it gets out of hand. But you could have a special situation where, let's say, there are only 3 search conditions that are indexed, and even more so, you're actually forcing the users to select one of these, and then all other filters are just extras. In that situation, you may want to do something like that. But most of the time, when higher call frequency is concerned, Dynamic SQL is a better solution for reasons that we will see later on in this presentation. Now, so far, all search parameters have been scalar as a single customer, a single city, etc. But many times users want to be able to make a multi-select. So we're going to add searches on employees to this mix, and the users are able to say, let's say, I want to make C orders by employees 1, 3, and 5 for customers from, let's say, Charlotte, whatever. And so and it's quite popular to do this with the comma separated list. So I would pass this one, of course, nullable, and then I say, oh, employee ID, select n from DBO, index or TBL. This is a user-defined function that I have added to Northgale. And, well, put this, employee CSV is null, so the same pattern as before. There's lots of these functions to unpack a list into a table. You always have to do this when you work with CSVs. There is a short article on my website that discusses some of the basic versions, and then this one links to a longer article. There's too many ways to do this, and that's, if you search the web, you will find even more. You might even know that there is a built-in one now, starting with this from 2016. I will talk about that one a little bit later. Personally, since we are in a database, and I'm a database guy, I like to work with tables. So we can do this as well. You can pass a table variable. So you have a TBL, and I need to have a table type. Again, this is a user-defined one. I've added to Northgale. It has to be read-only. There is no explicit default value, but the TVP always have the implicit default value of the empty table. Now, this one requires one extra step. I need to check whether there is state in the table and use this variable down here for option recompile to work. It doesn't work to put the exists clause here. But then it's the same thing. Yes, the employee ID in select val, the values I got, or has table equals 0. So far, the mechanism is the same as with static variables, but there is a little bit of problem for performance because the optimizer knows less. If we take a simple example case with the TVP, all it knows is the number of rows, but that's all. And well, if all employees have about the same amount of orders, it does not really matter because that's all the optimizer needs to know. But there could be a skew. let's say that some employees, they say screws and bolts, and they have tons of orders. Whereas other employees, they say Porsches and Lamborghinis, and they have just 2-3 orders per year. Now, let's say we're combining the employee with something else. So let's say we're combining employee and customer ID. Well, if we have a customer with lots of orders and the employee is the screws and bolts guy, well, the index on employee's ID is probably good. Oh, sorry, if the employee is Porsche guy. But on the other hand, if the customer is just an occasional customer and the employee is the screws and bolts guy with tons of orders, then probably we should use the index on customer ID. And now this was the TVP. Now, how do we deal with this with the CSV? This is the part of the presentation which I don't really like because it gets too complicated, but it's not really my fault. Well, I blame Microsoft. So anyway, if we have the string split is done with a multi-statement TSQL function, well, then this applies. If we are in SQL 2012 or earlier, the optimizer will make a blind guess on one single row, which actually I think in this context is not too bad because usually users will only put in, well maybe 1, 2, 3, or 4, hardly 100, just a few ones. But on SQL 2014 and 2016, the blind guess is 100 rows, which in most cases will lead to gross overestimate. Now, in SQL 2017 or later, this has been addressed. What they do now is that they first run the UDF, see how many rows it returns, and then compiles the rest of the query. And this will happen every time if we have option recompile. This is known as interleaved execution. So now we get on par with the TVP. We know how many rows there are. So this will work fine with an even distribution, not if there is a skew. Now, there's also this built-in function called string split, which was added in SQL 2016. Here, the blind guess is always 50 rows, even in SQL 2019. And you can bet I've been nagging the team to make interleaved execution here as well, because it doesn't really make sense. Then there's also other alternatives. For example, you can have written a string splitter in the CLR. I think the blind guess in that case is 1,000 rows, but I might go. But anyway, all other methods you use, XML, etc., you will get a blind guess. Thankfully, though, there is one final solution to all this problem to handle the skew or the poor estimates for CSV, depending on your method. You can take the data, put it in a temp table, because not only do you now get the correct cardinality, but you also get distribution statistics. So the optimizer can see what kind of employee you have. But even in this case, there's one extra step we are needed to avoid confusion. We need to do an explicit update statistics on the temp table, because else, yes, as it says on the slides, we could be running the statistics from the previous execution. That's one, it's a little bit hard to swallow. But this had to do with the fact that SQL Server caches the definition of temp tables, the metadata, to avoid contention on the system tables when there is heavy traffic on doing that. And they also cache the stat blob, the statistics, so that you can get interesting results. Okay, time for demo. So I got a file here called static search 5, which has no less than 5 different versions of this. So here's the, sorry, was anyone saying anything?
No? Nope, go for it.
Yep. Okay, so here's the one version with the TVP, and this one is read-only. Well, it's like before, so this is the one this is the one I showed you before. I got my variable here, and then down here I have the condition. employee select and has table equals 0. Option recompile, of course. This is the one with the UDF. Now it's a CSV, it's like a max there, and I got my condition here, employee ID, in my got return from this UDF, or the variable is null. Option recompile. Here I'm using string split instead, and when it's built in, you can see the code is actually longer because string split always returns the string, so I need to convert it to integer, and I also, well, that's of course smart. I can't specify the delimiter, the UDF I have up there, actually hardcodes come up. But again, it's the same thing. And here I got the temp table, and here I'm passing a TVP, but it could just as well be a CSV. It will be the same thing. Because I'm checking here, well, I'm setting this variable, then I'm checking, do I have any data in my TVP, or is my string null? I got my temp table here called hash emps, and then I say hash table equals 1, and then I'm filling it for my temp table, and I do update statistics. Oh, sorry, I'm filling it for my table variable, or my comma separated list if I would have that, and update statistics on it. And then I use it down here. Employee ID and select emp from hash emps or hash table equals 0. Option recompile. And then finally, temp, no UPD stats. This is exactly as the one before, except that this statement is commented out. So I will go on and create all these guys. Let's see here if I can go back. Yeah, let's see up here, and I got some things to try. So here I'm going to make a search for 3 different employees, and these employees, they are Porsche guys. They have in total 64 orders, so that's quite a few. Not very many. And you can see I got the same numbers here, different versions, and I'm going to run all of these for it once, and I'm going to run with the query plans enabled, so we can see how the estimates are. And you can see here it says 211 and 28,861. This is a fairly recent additions to the Query Plans Management Studio. You can see this. So this is the estimate. No, sorry, that up is the actual number, and this is the estimate how many rows it's assumed that it would process. And since this is the last operator before the select, this is also how many rows SQL Server thought we would get back. So SQL Server thought we would get back 28,000 rows, but we only go back 211 because all SQL Server knew was that we have 3 employees, and on average, an employee seems to handle these many orders. And why don't my start menu come up there? Oh well. So let's see, and let's move to the next one. This is the UDF, and here, for some reason, you can see here is the UDF itself. It's a 0 to 3. Why is it 0? I don't know, but 3 was the estimate. But for some reason, though, it thinks that now it will only get 16,663. Why this number is different from the TVP, I don't know. I haven't not dug into it. And here's the version with string split. And now we get an estimate of 68,026 rows, because if you move over to the right, we can see here that, well, 3 out of 50, because now it thinks that string split will return 50 rows. So that's why we estimated so many more rows. Now we come to the temp table, finally. And we can see now it's still an overestimate, but it's a lot closer. It's only wrong with a factor of 9. It thinks that slightly less than 2,000 rows. And when it comes to estimates, that's just not too bad, but it's as good as it can be, because now it knows that these employees that are on the temp table, they don't have very many orders. Okay, so we're going to make one more search. Now for a single employee, but this is a screws and bolts guy. This may be the guy with the most number of orders in the database. So I'm going to make a search for him for all 4. And now I get to know. Well, let's see if I can just get the scrolling to work. Oh, so here it is. Sorry about this. So now I got back 27,678 rows, but the estimate was only 9,620. So and these as overestimates can lead to bad things like excessive memory grants. Underestimates can lead to sort splits and all sorts of things, and also inappropriate choice of indexes. And here's the one with the UDF. Well, we got the same estimate here, 9,620, and 0 to 1 rows, because the estimated 1 row. I should say I'm running this on SQL 2019. And here is the string split version. It's still an overestimate because it still thinks 50 rows. So although this was the guy with the most number of orders, it's still a far out estimate. And look at the temp table. It's getting really close. This is just 0.9 approximately of the correct value, which is really, really good. 24,099 rows, or when the real value was 27,678. Also for fun here, let's now look at different compatibility levels. I said SQL Server versions on the slide, but what really matters is the compatibility level. So I can do this on SQL 2019. Compat level 110 is SQL 2012. This is SQL 2016. So I'm going to run these 2 searches. And remember, previously I got the correct, or I got an estimate. I got the same estimates for the TVP approximately, but it was based on the number of employees in the string. Now things are a little bit different. Here's 0 to 1, and it estimates 8,087 because there are 3 employees being passed in, but now it's making a blind guess of 1 row. But it's not too bad. Actually, we get a better estimate than when it gets 3, because these employees don't have very many orders. But here you can see we got a whopping overestimate of 96,000 rows because it thinks 100. So, of course, UDFs are used in so many contexts, but for this particular context, they changed this to 2014, which is not really good. And here's also the one with the no UPD stats. So I'm going to use this one first search for the 3 Porsche guys and then for the one for the employees. So, but and I'm not doing update statistics in between on the second one. Keep this in mind. So here, oh, let's see, where is that one? Yeah, there's this one. This is the same estimate as before because it was used the first time. There was no timetable cached. So, and it got the estimates right, 1,989 rows. But here, before, with the real version with the temp table, we were pretty close. Now we get actually an even lower estimate than the last time because the cardinality has been updated. But because we're using the same statistics as for the previous execution. If I actually redo this one once more, I believe now autostats will kick in and we will get the right values. But so that's why you need to do update statistics, because typically you will not make the same search twice. Okay, that was a whole lot of things on the CSV, a little more complicated than I would like it to be. But anyway, let's then move on. There might be other things we want to do in our searches. For example, this, let's just imagine, or in this database, there are actually 2 sets of order tables. There is orders and order details, and there's also historic orders and historic order details. And there might be an input parameter that tells the users, I want to search historic orders. And you can do it this way. So you have a union. So here you have the join between order and order details. Here the join between historic orders and historic details. And in the where clause, you only check the variable. And option recompile will factor this out so that in the actual query plan, you will only have 1 set of the tables. This works quite well, but the codes get a little more complex. If you have lots of these, it can become a little bit unwieldy. And then, of course, we might want to control the sort orders. And well, we can do this. We can use case to do this. So we say, okay, case at sort call. If it's already, well, then use already. If it's employee ID, use employee ID. But as you see, there are 3 case expressions. And why do I have that? Well, because I have different data types. A case expression returns always the one and same data type because well, SQL Server, SQL, is a statically typed language. So a case expression will always have a static data type. So I can't mix ID, strings, and date. If I try to do that, well, SQL Server will say either, no, there's no conversion, or it will say, okay, wait a minute, I can apply implicit conversion to the type with the highest precedence. And the highest precedence of these types is the date, which means that if you're going to try to solve the name, it's just going to end in tears and nothing will be good. So that's why you need 3 case expressions. But recompile will sort this out. Okay, if I sort on the date, oh, no, okay. Order, yeah, that's great. That's going to work out. But let's now imagine that I also want to have, well, a multi-column sort, and I also want to choose between ascending and descending. Well, let's have a look at that in this little small demo. So, this procedure I got as historic. I got sort call 1, which is default to order ID. It's descendant 1, sort call 2, which defaults to product ID, and it's descendant 2. So here I got the thing with it as historic. And you can see here, then I join the U to the customer's ID and product ID. So that's not very strange. And down here we get the order by clause. Well, it's descendant 0. Well, okay, sort call, order ID, etc., ascending. Then it's ascending 1. Well, and the same thing again, descending. And then it goes on, and it goes on, and it goes on, and it goes on, and it goes on. And the order by clause is about as long as the rest of the procedure. Now, this is a case where Dynamic SQL is a better choice because it just goes out of hand. And this is a good illustration of how it sort of grows exponentially when things get complex with static SQL. Before we move on to Dynamic SQL, we're going to look at a different search pattern, a different search problem for a short while. We want to look up customers in a table. And we could do that depending on what we get, either the customer ID, the tax number, or the name. And all of these columns are indexed. So what do you think about this pattern? Where customer ID equals at custody, and custody is not null. Or VATNO at VATNO, and VATNO is not null. Or customer ID like at custom plus %, and custom is not null. And there is no option recompile. Well, you might say to yourself, well, this is the same pattern as before, so this is not going to work well. That would be a table scan. But wait a minute, it's slightly different because the and or has changed places. Let's have a look at this. Let's have a look at this. I just can. So, yeah. So I got a simple procedure here called cost lookup. As you see, that's the same condition. I got a top 20 here because just in case they put in just a single A for the cost name, I don't want to overflow the UI with too many search conditions or too many rows in the result set. So I'm going to create that procedure, and I can make the search on barracks. Let's see what happens. Let's see. Of course, I want the query plan as well. And at first point, we might see, well, wait a minute, it's actually, yes, it's using all three indexes, but we only want to, but look now a little closer. It says here 0, 1, 0 of 1, and then also down here 0 of 1, etc. What does that mean? 0. Well, look at this one, this filter operator, and there's something very interesting here. There is something called a start up expression predicate. What this means is that at runtime, when the plan is going, this filter operator will look at that node. Oh, that node is not, but wait a minute, that node is not. I'm not going to call the other guy, what is behind me, to 4 rows. So this is a kind of it's a static plan, but it has dynamic elements. So SQL Server can build this plan with all these combinations, and then itself filter out at runtime which of the branches to use. So I can try this one on text number. And now it says 0 to 1 here, 1 out of 1 here, and then down here is 0 to 1, all the way. And I can do the search on the customer name. And now it's 0 to 1 there, 0 to 1 there, and now, well, 80 out of 1 because it returns many rows, etc., etc. So this is actually quite smart, because sometimes you can do these things. So this is known as a startup filter. The planner searches for all these indexes, and there is a startup filter that precludes the rest of the plan to be used. And this can be even more interesting if the operation is something quite expensive, like a scan. The condition that I added here at val or at customer ID is not null, must be that. It's actually redundant, because if we say customer ID equals at custody, well, if at custody is null, then it's not going to return any values. But the optimizer does not have that built in. We have to tell it for this to work. What I've found when playing with this, I haven't not gotten this to work if the search columns are in different tables. But you could try them if you want to. Overall, if you're going to play this game, always test that the plan is what you intended. Just don't assume that you will get stood up filters. You really have to test. And you also need to be aware of parameter stuff. It could trip you. So we're going back to this one, and I'm going to recreate the procedure. So I'm going to flush the plan, and now I'm going to run the search for the customer name. And this time, all optimizer says, no. That's just 2 minutes to use an index. I'm going to scan the table instead. Which means that when I run it for the text number, it also scans the table. It says 1 out of 20. Doesn't seem very expensive, but you have to be careful, because the numbers you see is not the full story. We can see that the number of rows read was 6,640, which is basically the entire table. So when you do this, you have to watch out and try. You try to try all of the input values as the sniff value, and if that doesn't work out, you might have to force or put in or use some hidden like optimize for, etc. Or of course, you can always use option recompile, but let's say you don't want to use it because you know this is going to be very frequent. Now, there are more cases where we can use startup filters. Here is another one. So that going back to our order search, assume that, well, users want to be able to search for orders where the supplier comes from a certain city, but we don't really care about the suppliers table apart from that. Well, then we can do this. So where supplier city is null or exists from the suppliers table. And we will only go to this table if this column has a value. Now, some people might say, yeah, but this is operator shortcutting. No. This is not operator shortcutting. There is no operator shortcutting in SQL. We could change these conditions around, and it will still have the same effect. SQL Server will always, SQL Server may or may not evaluate both sides of an OR or an AND, and it reserves the right to decide in which order it's going to evaluate. And here's another example where setup filter works. Yes, we have seen this one before. This was the one with the union. We don't really need option recompile for this case. This is going to be a setup filter. So this is actually really, really handy. If all that you need to do is this, you can trust setup filters here. But I like to put out again before we leave this topic, always verify that we have startup filters, that they're really being used as you intended before you go along, because it's not really one of the most exposed things in SQL Server. I think at this point, we could stop and see if we have any questions, Kevin.
Sure. We have a few of them. I'm going to go in reverse chronological order just because I can.
Yeah, do that.
The first question, or the last question, was, does the update stats in the stored procedure where you had a temp table and you were running update stats cause a recompile of a statement?
It does. Well, in this case, that question is sort of immaterial because I got option recompile down there anyway. So I want the statement to be recompiled. But yes, it's true. If I would have a static query without option recompile down there, that would be that would cause a recompile of the query. But again, I do have option recompile, so I want the recompile to happen for these kind of queries. But it's true, if you do up the statistics on a temp table explicitly, that will cause a recompile of all remaining queries. But with temp tables, you tend to get autostats quite often because for a normal table, I think the minimum for a small table, it has to be 500 updates before autostats kicks in, and then it is for 20% of every new route. But for a temp table that always starts empty, the first threshold is at 6 routes. So you often get recompiles due to statistics changes with temp tables.
Okay, that's a good point. So the question is, have you compared the performance of the between operator and your toDate operators?
Let's say this again. The between operators and the...
And where it's greater than a certain date and less than a certain date?
Well, between is actually, I think, syntactic sugar. So if you say x between a and b, that it really means x greater than a and x less or equal b. I think it even compiles that down in the tree. So if you, for example, if you don't have a column x because it was actually called y, you will get 2 errors for the missing column because that happens already during pastime, if memory serves. I hope that answers the question. I'm not sure I completely got it, but
yeah. No, it's a good point. It's basically it's going to be the same performance because it's the same thing under the covers. So somebody, as a comment, pointed out using this startup filter pattern for some reports, and just want to note that performance worked well. It's a pretty small data set, and users have a lot of fuzzy searches, so they were able to get that pattern to work.
Yeah, that's great. Yeah. Actually, I've also seen plans where I got a startup filter not based on the variable, but based on the column. So for every row, oh wait a minute, I want to go over to that part of the plan because this column. But that's even more. I think I've seen one plan of that, but I haven't been looking very carefully. It's not one of these popular things. For example, if you use, I'm not sure they fixed it, but I know that at one point commented out to send to one of their Plan Explorer that did not show these startup filters very much at all. And I think it's a great feature.
Yeah. So next couple of questions are actually about Oracle. I don't know how familiar you are with Oracle.
Let's see. I started my database career actually installing Oracle on a PC way back. I read the manual, but then I got into other things. I got to work with RDB first for a few years, and then SQL Server. So no, I can't really answer much more about Oracle, I'm afraid.
Okay. That's fair. I'll ask anyhow, and the answer may be I have no idea. The option recompile hint on statements. It sounds like bind aware in Oracle. Did bind aware exist when you were using it?
I know. Well, it was way back in the 80s, and I don't think I ever came around to run a query. I did read manuals. I had some time. I was working for consultancy, and I was out of a project for a while. So. And then I said they were doing this sort of a.
That's fair. All right. Sorry,
so
Jubu.
I never worked with it.
Sorry, Jubu. You might have hit the wrong group to ask about those questions.
Yeah. But that's all these things that happen. People get some idea. Oh, well, what about this? And of course, I could have maybe the fact that I actually worked with Oracle. I could answer that, but I'm sorry, I don't know.
Yeah, no, they're great questions. I just no idea what the answer is. So. Checking here, dynamic searches with XML or JSON. Does this help with any of this in place instead of using CSVs?
So you would pass the data as XML or JSON and crack it. I use CSVs here as an example, and DVPs. You could send in XML, but it's more or less the same thing as sending the CSV. You will get blind guesses. Same thing if you send the list as JSON. Unless you go to temp table, because it doesn't know anything what's inside the JSON or inside the XML. But the blind guess, now may be different depending on the method. I think for OpenJSON it's 50 rows. For XQuery it tends to be 200 rows. Don't ask me why they're using different from, but maybe as someone fluidized or something like that.
Yeah. That's so another question. How does this work for paging?
Okay, so yeah, I haven't. That's actually a great question. I guess I do not go into paging. I don't even cover it in my article. Maybe I should, but then again, paging itself is a quite complex topic. And also, I'm also kind of these things that, yeah, I never. So when I come to websites and I only see 20 rows at the time, I'm just getting, well, at least give me 100 at a time, or give me everything. I find just boring. And also, I would think also that if you want to do, even if you only want to show 20 rows at the time, maybe you should get a lot more so that you don't have to run trip every time the user presses next. But occasionally, if you can get 10,000 rows of hits, and the user might want to go to the end for some reason, not maybe go through all rows, but maybe just jump to the end, of course, then you will have to do something. But I think paging itself is a topic that warrants allow an article and presentation itself, and I don't have anyone on that, unfortunately. So, but it's not a bad question, of course. It's but I think even if you compare the static SQL and the dynamic SQL we're going to look at later, and I think both of them could be combined. But that's a bunch of techniques. You can rerun the query, add things, conditions where well site, or you can materialize the results once in a temp table or a work table, and then pick up the data. And that's the great thing with doing that, is that you don't have to do it, because if the search is slow because of indexes, etc., you only do the heavy lifting once. But then again, if you cache the results in a temp table or a work table, then you will know how to clean it up when the users to no longer look at it, etc., etc. But as I said, that could be a presentation of its own.
Yeah. The follow-up on the question was that they're using an intermediate cache and then query that cache. So it sounds like taking the results, putting them in a table someplace, and then querying that table, which...
Yeah. And also there's lots of variations depending on what you want to actually do. And I remember the first time I went to PASS, and the first presentation I ever went to PASS was actually quite interesting. It was called reading one page at a time. And I thought, one page, because I thought he meant the database page at the time, but it was about paging, and he had quite some interesting things there, including third-party products. For example, if you're looking at the log, you might want to 90,000 rows. You don't want to read all of it, but you might want to jump to different places. So that's, yes, it's quite a complex topic in itself. But yes, it's not certainly a question that is worthwhile. Maybe I should cover it in the article, or maybe not, because when you talk about something, you have somehow try to keep down the scope, or else it just goes to be very complex and readers get bored, etc. Oh well. Do you have any more questions?
I sent out the call for questions. So far, I think we're in the clear. I think that was all of the questions.
Right. But that wasn't good questions there. So now we'll move on and talk about dynamic SQL. So dynamic SQL, let me get this clear from the start. It is a higher level of difficulty. Not the least does it require more discipline from the program. Because, well, I've seen so many examples of dynamic SQL, which is just so very difficult to read. Sometimes it feels like it's easy to write dynamic SQL than to read it. And it's very difficult to maintain. And not only that, dynamic SQL requires more testing. And that may not ring a bell directly, but I will show an example of what I mean with this later on. Another complication is permissions. When you use store procedures, well, all you need to do is to grant the users permissions to run the procedures. But if you use dynamic SQL, there's no longer ownership changes that no longer apply. So you will have to grant the users direct permissions on the tables. Well, you don't have to, because there are alternatives. You can use certificate signing, or you can use execute as. I got a long article on my website that discusses this technique in general, in detail. Called packaging permissions instead of procedures. Also, for those who attended the Data Architecture Day 3 weeks ago, Solomon Rudsky also has a presentation about permission signing, or about certificate signing. So there is an alternative for this. But it still makes the solution more complex, because you have to do this as well. But all this being said, dynamic SQL gives you a lot more flexibility. So, the core of all searches with dynamic SQL is this procedure called execute SQL. And I'm quite sure that many of you know this one very well. but it's still so important, so I like to talk about it and dwell on it a bit. What you can say it does, it creates a nameless store procedure and save that to the cache and runs it at the same time. It's not saved to disk, but it's saved to cache. And next time you call that procedure, well, it looks up the procedure in cache and reuses the plan. Now, if the procedure does not have a name, how does you find the procedure? Well, so the identity of the procedure is a hash, which is computed from the query text as is. So there's no normalizing of spacing, upper, lower, etc., comments, whatever. Add one single space, and it's a new hash and a new cache entry, and potentially a new plan. This procedure takes a number of parameters. The first one is an SQL string to execute. Beware, it's nvarchar. Most of the time in SQL Server, you can mix varchar and nvarchar freely, and well, it might result in bad performance, but you will not get any errors. But every once in a while, SQL Server thinks, no, let's see if the user is awake. So I'm going to require nvarchar in this case. Varchar does not pass. SQL Server is just designed for maximum confusion. Oh, anyway, so the second parameter, well, that's the parameter list for this procedure. And again, it must be nvarchar. And the syntax for this parameter list is exactly the syntax for the parameter list for a store procedure. And the rest of the parameters, well, they're simply the parameter values for the values in parameter list. So let's look at an example. So in this batch, well, first of all, I got an SQL parameter. This is the one to run my Dynamic SQL. Always make this one nvarchar max. No exception, no reason to. You will always cause yourself a problem if you make it shorter. I remember one particular fun example in the forums. This guy had only gone for nvarchar 50, and his SQL string was 51 characters long. The params, well, I usually go for nvarchar 4000, but if you need max here, you have too many parameters. I got two more variables, but they are just part of the demo. These are always involved when I use Dynamic SQL. So here I got an SQL string. There's no reason to have this one dynamic, but it's just a simple example. So I say select at count equals at count or equals count star from db.orders where custody at custody. And then I can set up my parameters here, custody and car5 and count. It's an output parameter. Now, for dynamic searches, we will not get very many uses for output parameters, but I still wanted to show that it is just like the parameter list for a store procedure. And so here are some searches. I call this one. I pass the SQL string, my parameter list, and here are some actual parameters. This is a constant, and this is my count how I get the output. And here I do it differently. I don't use the parameters variable. I actually define the whole thing in line. I tend to do that when I only have, let's say, 2 or 3 parameters. If I have more, I tend to use a variable for the list. It's just what I feel like. And as you can see, I can also use name parameters here because it's just like a procedure call. And I can run this and we get back to 2 counts. Oh, well, we're going to look at dynamic search 1, the first procedure that is using this dynamic search on Dynamic SQL. What I will do now is I will first make a quick walkthrough through the code, and then I will discuss in more detail on the slides. So here, I got my parameters. I'm passing them, both my employees, both as a string and as a table. And there's also the debug parameter. Here's the SQL variable, my parameter list. This one I will talk about later. Here's the select list, and here's the join. And here I go on and add conditions. It goes on a little bit. I will discuss this in more detail later on. Here I add an order by clause. Here I use the debug. Here I set up the parameter list, and here I make the call. So go back to the slides and get in more details about this. So here's the first part. I declare my variable, SQL, my parameter list. This one I will talk about just in a second. And here I have the select list, my from, join clause, and a few things here to highlight. So first of all, this thing. You may have noticed that in my store procedures, I did not say dbo.orders, dbo.order details, because I think as long as I'm using store procedures where everything is in the DBO schema, saying dbo.orders is just 4 characters noise, so I don't do that. But it's different with Dynamic SQL because here it could have an impact. Let's say we have 2 users, Jack and Jill. And Jack, he has the default schema Jack, and Jill has the default schema Jill. Now, if you only say from orders, well, this means that at any point in time that it could appear a table called Jack.orders. And in that case, the query should resolve to Jack.orders and not dbo.orders. And for that reason, in that case, we will have to flush the query plan for Jack, but not for Jill. So that's why they can't share query plans. And because if every user has it that way, this means that we're going to bloat the cache with lots of plans for each user. We don't want to do that. But if we put in DBO, there is no ambiguity, and it will always be the same plan. Now, in practice, in many databases, or users do have DBO by default, but that does not have to be the case. This thing here, where 1 equals 1, is a truism, but the point with this one is simply, that makes it very easy to add conditions. We don't have to look, have I already added a where? No. I just put it there, 1 equals 1. The optimizer will realize I don't care about this one. And finally, this one at NL, add new line. So this is simply a constant of carriage return line feed. The reason with this is that I want my dynamic SQL bit to be decent and pretty, because every once in a while I will need to look at it, and then I can read it, and it's also split on over multiple lines. That's a nice thing, because then I can have line numbers to see whether I did have an error. And then I go on and add conditions. So I check. Well, if ORID is not null, well then if it's not null, then I add a condition and ORID equals at ORID. From date is not null, well then add O.ORID equals greater than from date. If custom name is not null, I add a condition at custom name like custom name plus %. And that's, I did not include all of them, but you can see the pattern is fairly simple and repetitive. A few things here to highlight. So this thing plus equals makes the code a little shorter. This operator was introduced in SQL 2008. So if you're still on 2005, you will not be able to use this, but this makes the code a little shorter. This is very important. After the open in quote, I have a space. And this is one of these discipline things. Make sure you always have this space so you don't have code running into each other. So this, you really need to make sure you do this. And then, yes, I do add this new line to every row. So I don't get all conditions on a single row. So if I get an error, I can tell where the error is more easily. And here, well, yeah, this one is for the single quote. If I need to include the single quote in the string, I need to double it. It's always the same thing. Now the multi-value parameters, how I deal with these. So, okay, for the table, well, do I have a date in the table? Then I add this condition. And then if I have the string, well, then I add this condition. Where employee ID select in from dbo.index.dbl. Again, I need to put in dbo here. Because if there's no dbo, well, it's any time if jack.index.dbl appears, we should use that function. And here's one really embarrassing thing for me. I did have this article up for several years on my website, but it was not until I made this presentation that I realized, I did not have dbo there. Now, there might be some, I'm not saying that this is actually really happening, but it has happened to me when I had a presentation. Someone said, can't we do this? Don't even think about it. Don't even think about doing this. And why this is bad, we're going to come back to this in a few slides. But before that, let's talk about the debug parameter. Every time you work with Dynamic SQL, you should always have this parameter at debug, defaulted to 0, and then have this statement. If at debug equals 1, print SQL. Always, 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 because every once in a while, there will be a problem in your Dynamic SQL. And if you can't see it, you have no idea, you're in a dark room, you will never be able to understand what went wrong. So you always need this. And here then the final part, making the call. This is a simple one. I just said that my parameters, all the parameters that I have, I don't have to care. Did I actually specify already? No, the parameter list is static, the call is static. There are some languages that would say, hey, you declared a variable at custom, but you're not using it. Thankfully, TSQL is not big about that. So this is quite simple. Now, let's go back and look at this procedure again, to the top here. And as you see here, okay, this was my parameter list. This was my variables. Here is all the columns. Here are the from and join clauses, filling them, dbo, etc. I'm adding all the conditions. It's quite a bit of the code. And down here, I got a token order by clause as well. Well, as I have with static SQL, I go on to my debug print, go on to the parameter list, and finally I got the execution. And this is, let's see here. Yeah, it's line 95, and there's a few rows in the beginning. So it's 90 lines of code, and I needed 4 slides to present it. Remember, static search 1 was one single slide more or less, and the code was a lot shorter. So that's what I mean with Dynamic SQL. It's more complex from the start. But let's now look at some of the test cases here. So I'm going to run this one for already 11,000. Let's look at the output. And once I'm here, it's simple. I mean, I'm not even going to look at the plan. This is going to use the primary key and all. Nothing can go wrong here. Nothing can go wrong. And well, here's another search on product ID and customer ID. And you see, I got this, customer ID equals customer ID, product ID equals product ID. Which index is going to use here? Well, yeah, that's maybe not really equally obvious, but it's probably going to work out. And here's an example, well, with a couple of employees and the customers from Oregon. Let's try this one. And I got here, C equals C region at region or employee in here. Well, that works quite great. So once I produce this, it's quite simple. But we can try one more example. Hey, this is the bug parameters for webs. I don't need this guy. Or do I must declare the scalar variable at city? What's going on here? Oh, let's see. Maybe a debug is not only for whips. Let's see here. What's happening? Oops. Press the wrong key. Sorry about that. Oh, let's run this again. And it says, yes, at city and what's going on? It's running together. That's why things are going on. Let's look at the code and see here. The search on city. Oh, some joker has commented out the new line. And what about the product then? Oh, look here. The space is missing. So, and this is what I talked about before. It requires more testing. This particular combination fails. City and product. Let's say I had also included region in the search. Well, there is a space, there is a new line. So I wouldn't have gotten this error. It's only this particular combination that fails. That makes a little bit devilish with Dynamic SQL. You really have to try sort of all permutations that, oh, this one fails because you did not have discipline enough to add those spaces. Now, the sad story is that here we use parameterized SQL. The sad story is that a lot of people, they're doing this. If already is not null, okay, and already equals convert varchar at already plus, well, they probably don't add the new line, but anyway. And then the city is not null, and city equals 3 spaces plus city plus 4 spaces, new line. I mean, why? This is a lot more complex to write, but probably they don't really understand this thing with parameterized SQL. But here is the employee string. Yeah, this one seems simple. SQL string and employee ID, and well, come on, this. It's great. And this is exactly what I told you not to do. So I got a procedure here called dynamic search bad. Yeah, yes, it's bad. So it's only got the string, it doesn't have the table. I actually got my new line, so I want things to be pretty when I look at it. Here's to select this, and then you see I'm going, everything's being inline to the query, all values. I'm not using parameterized SQL, and I'm not even using exec execute SQL. I'm using exec with SQL in parentheses, an older form of dynamic SQL that was introduced in SQL 6.0. SQL SQL was a little more modern. It was added in SQL 7. So anyway, I'm going to create this bad guy. And let's see here. Well, I'm going to run these two. I'm going to use both dynamic search 1 and dynamic search bad to search for a specific order. And I got the same result. So far, so good. And here it says it already. So this means if I search for now order 11,002, well, it will be the same query string. So it will be the same plan. But here it says 11,000. So if you now change this to 11,002, it will be a new hash. It will be a new cache entry, probably the same plan, but I'm going to bloat the cache. Here I'm looking for customers who have ordered the product Stout and who are from Lviv, a very beautiful town in western Ukraine. If you ever get over there, I really recommend you to visit it. But and as you can see, it's written in Cyrillic letters. So I'm going to run these, and oh, this one does not return any rows. This one does. Why is this? Well, you may notice here that there is no end up here. So this is a varchar literal. It becomes a varchar literal. Here, if you look at the output, it says Viv, but it should really say Viv with end before. So it's because I'm using a Finnish Swedish collation, so Cyrillic letters are not there. They will just be replaced by question marks. So the bad programmer who wrote this really should have put in an N here, or maybe it's here, or maybe yes, dynamic SQL, when you do things like that, it's just difficult. Don't do this. So anyway, here's another one. I want to find orders for customers who are located in the same city as the customer rexy, but I don't really know which city that is, so I'm just going to look it up from the customers table. I'm going to run that, and I get incorrect syntax near Emilia, unclosed quotation mark of the character string, because, well, the city in this case is Reggio Emilia in Italy, and there is a single quote in the name, so that was the end of the character literal, that was the end of the string, and this is just a syntax error. Because again, this was nothing the programmer did consider. And again, if you do inlining, you will have to handle this. It's a lot more complex than you think. And then we have this, and you're saying to yourself, okay, employee string, 0 parentheses, exec command shell, different C color, select star from select, one is already, as hyphen, hyphen. And you're telling yourself, okay, this is going to explode big time, just like it deserves. Well, let's see here. it did not explode. It returned 3 results. It's first an empty one, and then this is the contents of a C drive. Oh, I'm glad it did not say format C colon. And then no array. So what happened? Well, let's look at the output. Well, so it says 0 parentheses, and that's the end of that query. Here is exec command shell. And then we added some stuff here to handle this order ID. And these hyphens here, well, this parenthesis was originally intended to be up here, but now it's been commented out. Now you might say to yourself, yeah, okay, this is funny, but on a Friday afternoon, hey, wait a minute, I'm just want to get home. To kids and family, oh, well, you're probably already home, but you want to get out of the place where you're sitting watching this presentation. So I don't have the time for this. Now, in a way, this is the most important part of this presentation. What you have seen here is an example of SQL injection. And SQL injection, this is nothing that lone teenagers play for pranks. Now, the people engaged in this, they do this for money because they can make big money for this. They can use this to install ransomware, to steal data or whatever. And, well, yeah, but they would never find this hole. Of course they will, because these guys have lots of times on their hands, and also they have quite good tools. I don't know exactly how long time it would take them to find this, but probably not a very long time. Use my hand to take some water. So this is, well, bad. This was bad for a number of reasons, but the biggest reason this is bad is it opens for SQL injection. So don't do this. Okay, we're going to move on, and we're going to talk a little bit more about cache and compilation. So if we do this, we use this procedure static search for with RECOMPILE. And we search for 3 different OR IDs. We get 3 compilations, and that's 1 cache entry, which is never used, but it sits there. And then if we do dynamic search 1, well, we get 1 compilation and 1 cache entry. And that's why dynamic SQL is so much better for if we have high call frequency than static search with RECOMPILE, because we're using cached plans. For each combination of search parameter, that will be 1 plan. So if I would add a new condition to this one, also let's see, well, I will only see the products 25 from this order. I will get a new cache entry, but only for that particular combination. And if I use dynamic search bad, I get the worst of both worlds. 3 compilations and 3 cache entries loaded in the cache. That's also one reason this is bad. Here's another angle of it. So to the left, RECOMPILE, to the right, dynamic SQL with search with parameters. So RECOMPILE, cache compilation every time. Dynamic SQL, I get a cache plan per combination of parameters. This means that, well, with RECOMPILE, I will get more compilation than I need, because every once in a while, I will produce the same plan. With dynamic SQL, I get a lot less compiling. But this cuts both ways, because with RECOMPILE, the plan will always fit the current parameters as good as it can. Whereas with dynamic SQL, I get a problem with parameter sniffing. So let's have a look at this script. And what it does, this script, is that it's making 3 searches, 3 different searches here. And for all 3 searches, I'm using static search 4, dynamic search 1, and dynamic search back. For all these 3 searches, and I'm taking the time on all of these. The first search is, I'm searching for this customer, ER to see the guy with the most number of orders in the database for a single day. The next search is Bolasar, which has a single order, but it's a full year. And the last search is for status equals E. And for everyone, I'm taking the time. I'm going to run this, and let's see what times I get. This is a little bit interesting because I don't always get the times I want. But so for the first one, it seems that dynamic search bad is actually faster than the other 2. But that's a mirage. The reason for that's one faster is simply this. You see, here's the grid for the first 2, but not the last one. It takes time to render the grid in Management Studio, and I'm running Management Studio on the same virtual machine. So you have to watch out when you're doing these performance tests. But you can see here for Bolasar, it's clear that dynamic search 1 is a lot slower than the other 2. The same thing for error orders. So let's study why this happens. Well, if we look at this guy, to see, we're running dynamic search 1. Let's see what plan we get. And this is the same plan as we saw before. It's using an index seek of both the order date index, both the order date index and the custom ID index, and then making a hash match. Now let's see. We can take a look at the static search for Bolasar and a single day. You might recall this, but if you don't, it makes an index seek on the custom ID index and a key lookup. It's not using the index and order date. Whereas dynamic search 1. We look at this plan here. It's still making use of both indexes. And then this hash match, you might see here that there is a triangle here, which means that the hash match is split into disk. Because it's a cached plan. So it's reusing the same plan. And this time the plan did not work out very well. And then for the error orders, well, let's see. Static search 4 is using index seek on the status X. Great, the filtered index. But dynamic search 1, what is it doing? It's because it's so much slower. Let's have a look. Oh, let's see. Wrong plan. Get it here, and here, over here is the orders table. It's clustered index scan on the orders table. So it's not using the filtered index. Why not? Well, because this is a cached plan. Okay, but wait a minute. You say it's a cached plan, but we have not run this one before. When we were sniffing it for the status E. So it could use the filtered index. Yeah, but it's a cached plan. Meaning that the plan must also work for value C. So therefore, we cannot use the filtered index. So this is some of the problems you can run into with Dynamic SQL. So you don't get optimal performance, which you don't have with static SQL, because you always get a plan that is shaped exactly, or static SQL with optional recompile, because you always get a plan that is shaped to the current parameters. Now let's see what we can do to handle these situations if they will happen to be problems for us. Well, obviously we can do this. If we know that this particular combination is sensitive, customer ID and a date interval, or in a date, then we say, okay, I don't really know, so I'm going to put it up for recompile. And I know that this search is not frequent enough, so that's not a problem. But of course, if call frequency is a concern, we have to look for something else. Here's another idea, which is a lot more difficult to do. But what I do here is I look at the length of the date interval, and then I add a comment. Seems like kind of meaningless, but because it's more text, the cache changes will be different. So I can different cache changes depending on the date interval, and therefore potentially different plans. This requires that you understand your data quite well to see where the cutting off points might be, and it's far less granular. It's a lot more difficult to get right. But if you have really high call frequency, you might want to try this. Another situation you could have is this: that let's say that 60% of all the customers are in London. So then you want to tell yourself, okay, the plan for Paris is not going to be good for London, and vice versa. So then you say, if you have this situation, it might be a good idea. It's London, I'm going to say London right into the query. So I get a separate plan for London. And then I could have, else I'm going to use city. So I can use a cache plan for that. And we have this status column. Well, we might actually say this, there's only 4 possible values. And I could say, hey, actually searching for new orders and searching for error orders, that's 2 different searches. I'm going to inline that column. And I'm using this function called quote name, which means that, well, and with the quote as an operator, so it's going to put the quotes around it. And that's a safeguard in case the status would be a single quote, so I don't get the syntax error. That's for the city name and everything else. That's what the bad programmer should have used. It should have used quote name around the whole thing. But beware, only inline values, don't do this on a general basis because you will litter the cache, all sorts of problems. But for specific values, it can be a good thing in one way or another. But there's a different method also to handle the filtered index. I can also do this. If the status is not C, I can simply add the condition to the query. So then now the optimizer might think that I can use the filtered index. Let's see, look, some Dynamic Search 2, which has some of these virtues. So here, I'm doing this. I'm adding, if it's not C, I'm going to add the condition status is not C. If I do have a date interval, I'm going to add the comment. And here I got the thing on London. So in this database, London is not really 60% of the customers, but just as an example. So if it's London, I'm going to put in London, else I'm going to use city. So I'm going to create this guy. And yep, here I'm going to make the search on error orders. Then I'm going to look at the plan. First look at the query. It says status at status and status is not C. And yep, index seek order status X. So that's help to filter index to be used. And then we can look at these 2 searches again. And we can look at how the code is. It says a single day. It says more than a month. It's just a comment. But if we go and look at the plans, Here we have index seek, index seek. And if we scroll down, we have index seek and a key lookup. So that did help us to get different plans. And here we're going to search on cities. So the first one is, well, for a certain product for customers in London. And here is search for the same product for customers from Newburn. We'll make a search of this, and we can expect that we get more hits, much more hits from London than from Newburn. And if we look at the query, here it says London. Here it says city. And if we take a brief look at the execution plans, so there's the loops, class and index, there's the loops. Yeah, well, we don't going to go into details, but we can tell that the plans were actually different, so it did help to get different plans. So more things we can do. Well, sort we talked about for static SQL. Let's now talk about this for dynamic SQL. This seems quite simple. We could just say at SQL order by plus a sort column. How neat. We could just sort a sort column could be a list of columns with ascending, descending included. Not so quick, not so quick. There's a risk for SQL injection here. Don't do this. We need to use quoting. Now you might say, wait a minute. That's not a problem because I'm writing the client code myself. I got full control. There's no risk that users can make SQL injection here because I'm not permitting them. Never make such assumptions. Today, you might be writing your procedure for a fact client. But 2 years from now, someone says, oh, let's make this a web application. Let's expose this on the internet. And, well, the programmer who writes that one is just going to pass the data in the URL. And it goes right into the procedure. It's wide open for SQL injection. So each component should make its job. So if you write a stored procedure, it should not be open for SQL injection by any means. So you can use this function quote name. And if you don't specify what it should be, what the limiter should be, it will be right brackets. And if there is a right bracket in the sort call, well, it will be double. So that's why it protects against SQL injection. But if you do this, of course, you cannot have lists. You will need a sort call 1, sort call 2, or you could decode a sort call like being XML or whatever, but it's not going to be that simple. So then I think actually, and also, yeah, if you do this, I like to point out that there is still dependency between the client and the column names. So if you decide I'm going to refactor the database, it's going to use a different convention for my columns. But I don't like that. I don't hope that does not affect the client. But if you do this, it's going to affect the client. So I think this is kind of better. I simply say a case, same thing I did for static SQL. I do a case, but it works slightly different because now rather than saying O.ORD without quotes, it's now within quotes. And because I'm only returning strings, I don't need 3 different case expressions. I need a single one, and I can easily tag on ascending, descending. So if I want more sort columns, this is only going to grow linearly. It's not going to explode exponentially like it is for static SQL. And when we come to the demo, I'm going to show you a different way to do it as well. And one thing to point out when you do this, though, you must have an else. Because just in case the client decides to, let's say, well, something you did not, or product ID, and you do not have this in the procedure, and if you don't have an else, you will get null back, and nothing would happen. Not even your debug SQL will work because there's nothing to print. Everything's null. That's bad. So always put in an else with a default, or at least something that gives a syntax error if you want that. Alternate tables, again, don't sit in table names, don't do that, but rather have something that translates to a name. So, for example, we have this at historic, and I can do the same thing here. But instead of the union, I'm just building the string differently. Okay, at historic, when 0, then orders. When 1, historic is orders. And this is not too difficult to do. The difficult, I think, here is to write in the structured way so that you can read the code when you come back and look at it a few months later. That's the biggest problem with Dynamic SQL. It's not so much writing it, so much reading it a few years later, because that's when you need the discipline. And we have Dynamic Search 3. That's going to make some illustrations of this. So here we got, I got the string of the table, and here's the extra parameters. It's historic, sort code 1, default stored ID. Sort code 2 defaults nothing at all. And there's the debug parameter. And here I'm having as historic, building this way. I don't think this is too difficult to read, but I wrote it myself, so someone else may think differently. That's also a challenge with Dynamic SQL. Someone else is going to read your code. And down here for the sort column, as I said, I do it slightly differently because I have 2 of them. I set up a table variable, and here I have a mapping. So it's the same idea, but rather than doing it in the case, I'm doing it in table variable so I can reuse it. So here I say SQL, order by, and select my column expression for name call map, but I do need an isNull in case the client set down something I did not foresee, so I do get a default, and then I can tag on ascended, descended. Did I get something here in sort code 2? Well, then I will add a tag on the comma, and do the same thing and add this one. And this could probably maybe be beautifying if you have, let's say, if you want to support 5 sort columns, you might want to do something even smarter than repeating the code. That's what you can do with Dynamic SQL. And let's see, do I have some examples here? So I do have some test cases there. So we can have a look at these. So here I'm passing a product ID and a city and an order ID by order ID, and this is send one. And now I did not have this special handling of London here. So now we got a city, a product ID, and order by order ID descendant. And here I'm sorting with 2 columns, customer name and order ID, and none of them are descending. And you see all customer name ask, order ID descending ask. Now we can go on and add even more complex things. Let's say we want to permit the users to, well, I want to group by things. I want to aggregate. I want to be able to select which columns I want to see, etc. So I would like to say that is the limit for what you can do with the Dynamic SQL inside of the procedure as well. It's not so much that you, of course, you can do this, but how would you express all that in the title, in the parameters? That's sort of a fairly well, how should I put this? Narrow thing to get through the parameters. Of course, you could build some XML document that says exactly what you want, then you can unpack, etc. But really, I think if you want to do it this complex, it's probably better to do it client side. Do it in the class with some nice object-oriented interface. And I like to point out, there's nothing wrong with doing that. Well, as long as you can handle the permissions. Obviously, if you do it client side, the users must have permissions on the table. There's no certificate signing or whatever. But as long as you can accept that, that's perfectly valid for something which is that dynamic, because all you're doing, you're really building strings to string manipulations. And most languages outside SQL is better on string manipulation than SQL. But there's one thing you must never do. Never build some syntax in the client and pass that to a procedure. That's completely red flag. And the main, well, first of all, it opens for SQL injection. Second, you get a very tight coupling between the client and the SQL thing. And it's going to be very hard to maintain and do all that. So never do that. Do it all client side or do it all in the procedure. I like to point out, when I say when you are doing all client side, I mean these particular searches. You might still use the procedures for other things, like say storing an order, etc. But for specific functions, it might be better to use Dynamic SQL. Also client side things if it's very dynamic. So this, I'm getting towards the end of my presentation. Just to make a quick summary of what I've talked about. So for these searches, there are a couple of patterns we can use. We can use static SQL with option recompile. We always needed this guy. And it's good for the simpler cases, but if we add things to it of different things, complexity tends to grow. We also look at stub filters. I like to stress this again. In that case, you don't need option recompile, but you need to test that you actually get these. You have some variables that sort of controls and makes the plan dynamic. Dynamic SQL, I would say for the simple cases, it's just too much hassle. The coding is longer. But if you need to add more things, it tends to scale a lot better in complexity. So what to use is a decision to make from case to case. When in doubt, I would say start static, but be prepared to switch dynamic if you see it's getting out of hand. So that was all I had to say. My name is Erland Sommarskog. There is my email address. If there is some question you didn't get answered today, please feel free to reach out to me. Slides and scripts are there. sommarskog.e/present for both the slides and the scripts to build a database. And you need to run 2 scripts to build a database. This one builds Northwind and this one builds Northgale. So, yeah, do we have any more questions, Kevin?
Yes, there's one question, and I figure if I stall for just a little bit, maybe people will have additional questions. But the one we've got, the one we have is when you're using the dynamic SQL approach and you want to use common table expressions to do dynamic searches. A, is it possible? And B, would you expect any performance issues with that? No,
of course you can build a query with the CT, no problem. And performance issues, of course, that depends what you put in the CT and so on. So see, keep this in mind. The CT is that's just a logical way of expressing your query. And the CT may never be computed as such because the optimizer may realize, wait a minute, I can compute things in this way. It's just sort of it's a query scope view, so to speak. But yes, you can build, if for some reason you're going to make a search for an aggregation, or that is something you want to have pre-computed and you don't want to repeat all over the query, use the CT. It's a great tool.
Yeah, makes sense. Looks like there are no other questions. Just several people saying excellent presentation, great job, good enough to watch 2 or 3 more times.
That sounds great. Yeah. Thank you very much. Yeah, it was really fun to talk to you over there in North Carolina. So, yeah, North Carolina is actually one of the, I think I've been to 6 states in the US. North Carolina is one of them. That's just because Pass was there in 2013. I did not only went through I only rode through the triangle by train though. I was flew into Charlotte and then I went out to the coast to Newbern and other places. But it's a great thing with these. Well, but the good and the bad things with this Corona thing is that I get the chance to talk to places I wouldn't gone to elsewhere. If I hadn't been for this, maybe I would have been in SQL Saturday somewhere.
That's fair. That's true.
But well, it's a different year this year. But so if there are no more questions, I'd like to thank you very much. I hope you will have a nice evening. I will soon go off to bed, where I am.
And, yeah, it looks like that's it.
Thank you very much for listening. Thank you very much to Kevin for hosting the whole thing. It was a pleasure. And again, if you have more questions that did you arrive to you when you do the evening or tomorrow, whatever, drop me a line.
All right. Well, thank you so much for taking the time this evening, and we'll let you get to sleep.
Yes. So yes, one thing more, Kevin. So what do you have any? How many people are watching this? I saw it was something like 43.
Yeah, I get the stats after this. I'll get an indication. I'll be able to email that to you overnight.
Yeah. Okay. Yeah. Oh well. Yeah. Thank you very much, and have a nice evening to you.
All right, thank you. So, as we wrap up for today, thanks again to Erland for taking the time this evening to talk to us. We have a few things scheduled on the TriPass meetup. So, starting on Monday, we have Shop Talk yet again. After that, on Tuesday, we're going to have our advanced DBA group, where Pamela Hood is coming in to talk to us remotely. After that, I'm just going to stop talking about Shop Talk. Just imagine it's pretty much every Monday. But third Tuesday of the month, we're going to have Melissa Coates talk to us about administering Power BI. This is a brand new session for her. She's building out a lot of training in that area, so should be excellent. And then for the fourth Tuesday on June 23rd, Rick Pack will be talking to us about working with Excel workbooks in R. So we're going to have quite a few things going on this month. Hope to see you next time. Have a great day, everybody.